Hi guys. So we are starting a new topic today. It's kind of nice that we're starting something new. For those of you who haven't been checking in and working on the homework that I've been posting or watching the videos, this is a really good place to just start kind of fresh. So today we're going to talk about what is called law of signs, and it's actually in chapter 5 of your pre-calc book. We were in chapter 4 with all of the other trigonometry stuff that we were working on, the graphing, and before that, all of the triangle trig. So today we're going to start again a new section in chapter 5, and this is called law of signs. So the question we're going to answer today is, what do you do if it's not a right triangle? Because everything we've done so far has been with right triangles. This is the first time we've talked about what do you do if you don't have a right triangle. So let's just say, for example, that I have this triangle. This big angle in here is 100 degrees. This smaller angle over here is 35 degrees. So we could find the third angle, and it's clearly not a right triangle. So if I ask you to solve the triangle, what does that mean? That means to find everything we don't have. So let's say we have this piece over here, which is 22. How do we find all of the missing pieces, which is two sides, and the third angle if it's not a right triangle? So without it being a right triangle, we can't use any of our trig ratios, the opposite over the adjacent, the opposite of the hypotenuse, the sine, the cosine, the tangent. We can't use those. And we can't use a squared plus b squared equals c squared, which is our Pythagorean theorem. All of that works if it's a right triangle. So what if it's not a right triangle? So let me erase this. I'll put this back up in a second. We're actually going to solve this exact triangle. Ooh, this doesn't erase very well. If you notice, my whiteboard is slightly bigger. So nobody is delivering stuff that's not essential right now, which means I have a bigger whiteboard on order from Amazon, but it's not coming for another like 2 weeks. And I've looked at stores and I can't find any. So I got this little sticky stuff, which makes for a bigger surface, but it doesn't erase very well. So we're going to do our best. And then maybe I'll find some cleaner for it or something. Okay, so how do we solve a triangle that is not a right triangle? So let me just draw one up here that is not a right triangle. We're going to label this with A and B and C. We use capital letters to notate that we are talking about an angle. And we use lowercase letters to notate that we are talking about a side. So, and we always label the side opposite of the angle with the same letter. So if this is a capital A, the side opposite of this would be a lowercase a. And then, of course, the side opposite of angle B would be side B. And then the side opposite of angle C would be side C. That's just general notation practice in any kind of triangle trigonometry stuff. So that's the case. So how do we solve for the missing pieces? So we have what is called the law of signs, and it works every time. So the sine of angle A, this is not going to work, divided by side A is always going to be equal to the sine of angle B over side B and the sine of angle C over side C. Now, you don't need all three ratios. What you're going to do is you're going to pick two of the ratios and set them equal to each other. And then you would use the two ratios to solve. So you would never use all three of them together. What you want is an equation, right? A ratio on this side, a ratio on this side, and then you solve. So this is the general rule, or this is the rule for law of signs, given any non-right triangle. It actually works on right triangles also, in case you didn't know. Just generally we use it because right triangles have lots of other options. Okay. So I'm going to put that other triangle we just talked about a second ago back up here, and we're going to actually solve it using this law of signs. I'm going to erase. Again, I have posted the notes, which is everything that I'm going over right now. So feel free to take your own notes or open up my notes and take a look at them, and then just, kind of follow along as I explain them. Up to you. Depends on what you're most comfortable with. So that's 100 degrees. This is 35 degrees, and then the side opposite of 100 is 22. So our first step would be the easy thing, which is to solve for that third angle. So we know the three angles in a triangle have to add to equal 180 degrees, right? So if we know that angle A is 100, and we know that, let's call this A here, B up here, C over there. We don't know B, but we know that C is 35 degrees. And that total, that has to equal 180. Let me just add or subtract, however you want to do that, to find that angle B is 45 degrees. So now we know all three angles. So how do we find the two sides that we're missing? I told you a second ago that we're going to use our two ratios, right? We're going to use two of those three ratios. So which two do you use? Well, you find your pair of information. So this is angle A, this is side A over here. That's a pair of information. I have side A and angle A, which is going to go into one ratio. So we'll put the sine of 100 over 22. And then in the other ratio, you want to use one of the two things you don't know. So if we know that angle C is 35, and we need to find side C, which would be over here, I can use the sine of 35 to find side C. And then it's just a matter of solving this little equation. So this is called a proportion when you have two ratios equal to each other. So a fraction equal to another fraction. And we can use what's called cross multiplying. I don't know if you guys have seen this before, but you multiply the C times the 100, you multiply the 22 times 35, and it looks like C times the sine of 100 equal to 22 times the sine of 35. Then the sine of 100 is just a number. You can calculate that in your calculator. If you have a calculator, a scientific calculator, right? You can use the sine button on there. The sine of 100 is 0.98, whatever. You can also use your cell phone as long as you turn it sideways, right? As long as you turn the calculator on its side, you should have a sine button. My iPhone has the sign right there. So that works. So the sine of 100 is 0.98. So to get rid of the sine of 100, since it's just a number, I'll divide that from both sides. And so then this ratio, this 22 times the sine of 35 divided by the sine of 100 is what you're calculating. And go ahead and round that just to the 10th. So we get 12.8. So side C is 12.8. From that. Now, if you're using your calculator on your phone, it's tricky. The thing I don't care for and would prefer you use a regular scientific calculator is when I type in 22 times the sine of 35, the process is pretty annoying. So I have to type in 22. Sorry. I have to type in 22 times. Super annoying. I'm not going to show you. You get the idea. It's annoying. So just be careful. If you are using your phone, be careful how you type that into the calculator. Okay, so step 2 was this. Step 3 would be then to find the other piece that's missing, and that would be side B. So we know angle B. So we're going to do essentially the same thing we did here. We're going to start by using our sine of 100 over 22 again. Now, you do not want to use a number that you found to find another number. Eventually, we're going to have to do that sometimes. If you can avoid it, you should, right? If you use a number that you found, a derived number, and it's wrong, then everything you use it for after this is going to also be wrong. So don't do it unless you absolutely have to. So there are some situations where you have to. But in this case, we don't have to. We can go back to our sine of 100 over 22, and then we're solving for the sine of angle B, which is 45, over side B. And from here out, the process of solving is exactly the same as what you just did. So it's not super complicated. You would end up with B times the sine of 100 equal to 22 times the sine of 45, and then dividing by that sine of 100. You get the ratio 22 times the sine of 45 divided by the sine of 100. And then again, rounding to the 10th place, just one, you get the side B is 15.8. Now, once you have all your answers, a good check is that the longest side should be across from the longest angle. So if my angle A is 100, my side A is 22, then the two sides B and C should be significantly smaller, or at least a little bit smaller than 22. And they both are. And so 35, which is angle C, goes with 12.8, and 45 goes with 15.8. 15.8, since 45 is bigger, should be slightly bigger than 12.8, and it is. So you can always just double check yourself to see if you're getting the right. Now that doesn't tell you if you're getting the right answer, but it does help you check to make sure that you're in the right area. Oh, Isaac, it says it's unavailable. Weird. Okay. So I'm going to erase all this and then we'll do another one. Okay. Let's see how good it can, if I can erase it enough. That's not looking good right there, is it? Yeah. So I found this sticky stuff at Home Depot, which, whatever. I couldn't find it anywhere else. I definitely need to get some cleaner for it if I'm going to keep using it. So who knows where I'll find that. So in this next example, they're not going to give you a picture. They're going to give you the angle C, which is 103 degrees, side B, which is 46, and side C, which is 61. Now, how I know that that's an angle is obviously the degree symbol that labels it. In your book, when you're looking at this assignment, the C's are the only ones that are confusing because capital C looks just like lowercase c, except it's bigger, right? So just be careful that you know that those are two sides and that's an angle. So what do we know? We know that we have a pair of information. In order to use the law of sines, you always have to have a pair of angle and side that go together. So in the last example, we had capital A, which was the angle, with lowercase a, which was the side. In this situation, we have a pair of C's, angle C, side C. So that's your indication of what you're going to start with. So for step one, notice in this example, different from the last example, we had two angles. So we could subtract to find the third angle. In this case, we only have one angle. We don't have a second angle. So we can't subtract to find the third. We have to start with our pair of information and find the piece we don't have. So the sine of angle C, which is 103, over side C, which is 61, equal to, and this one we will use the B piece of information, but angle B is what we're missing. So we should have the sine of 103 degrees over side C, which is 61, equal to the sine of angle B, which we don't know yet, over side B, which is 46. Now, you could go ahead from here and do your cross multiplication like you did on the last one. What I want you to notice, though, is that actually adds a step to your work because sine B right there is to get it by itself, all I have to do is multiply both sides by 46. So absolutely, I could do my cross multiplication like I did on the last example. It would add a step. Don't feel bad if that's what you want to do. Since I recognize that to get the sine of B by itself, all I would have to do is multiply both sides by 46, I can go ahead and do that instead, and it's a little faster. So 46 times the sine of 103 over 61 is equal to the sine of angle B. Now, I don't need the sine of angle B, I need angle B. So how do I find angle B? To find angle B, right, if the sine of angle B is equal to this ratio, then B would equal the inverse sine of that ratio, like so. And again, that's just a calculator problem. You're just going to type that into your calculator just the way that it looks. What you want to be careful of is, again, the phone calculator, when you turn it sideways, mine does not have an inverse sine function. It's possible that it's there somewhere and I shouldn't see it, or there's some way to get to it. I don't know. But mine does not have that. And if you have the sign with a little h after it, that is not the same thing. So don't try to use that. So anyways, this right here is what I'm going to type into my calculator. If you do not have a scientific calculator at home, I actually had to go to school to get mine because I didn't have mine at home. If you do not have a scientific calculator at home to use, you can go to Desmos. There is a scientific calculator on the Desmos site. So please do that, or just Google one or whatever. So anyways, once you do this, you end up with this angle B, which is 47.3. Again, I'm just going to round to the 10th, 47.3 degrees. Now, the next step, which is to find the third angle, right? We have angle C. We know that the three angles of a triangle have to add to make 180 degrees, right? We know we don't know angle A. We know that angle B is 47.3. We know that angle C is 103. And then here we can subtract, oops, that's supposed to be 180. And then here we can subtract to find angle A, which ends up being 29.7. Now, here's the situation where there's no other way really to find angle A other than to subtract from 180 the B value that you found. So this is, there's nothing else we can do. We have to use that derived value. And then if this was a testing situation, obviously, I wouldn't mark you wrong entirely if you used this derived value to find that one and so on. So, but again, we go back to our 103. Oops, let me change that. And then 61. And we want our angle A. We have angle A. And our job is to find side A. Now, what I'll notice at this point is that 103 was the biggest angle, so 61 was the biggest side. Angle B is 47.3, side B is 46. So now as I go to find side A, I'll think to myself that this value for A should be smaller than side B, which was 46. Just as I work through it, I should remember that. So I multiply both sides by A, or this is the situation where you would want to use your cross multiplying. And you solve and you find that side A is 31, like so. Now, at this step right here, where you found your angle, the very first thing we did, if at this point your calculator gives you a domain error, that means that the information that you have does not create a triangle. Try to picture like you have an angle and two sides and they just don't quite reach. They just don't quite fit together. So this is a no triangle situation. It is possible in your assignment today to get that as an answer. So keep that in mind. So anytime you get that domain error on your calculator, when you try to use the inverse sine, it should only happen when you at this step right here, where you try to use the inverse sine to find that first angle. So that's everything. We're done for today. That's a quick video. All right. See you later.